Привет. I know no more Russian than that, I'm afraid. So I'm English. I tend to speak very quickly. I will try and slow down how I speak so that everyone can follow. If I'm going too fast, just raise your hand. I will probably see you, and I will try and slow down and be comprehensible. Yes, I didn't understand a word of that introduction, but I did hear Selenium. I am the lead of the Selenium project. Strangely, this is not a talk about the work that I do on the Selenium project. I recently joined a food company in the UK called Deliveroo, and on the second day, my manager sits down next to me, and she sighs, and she goes, "I hear you hate the name quality." And I went, "Actually, I do hate it. It's a terrible name." And being the patient and lovely lady she is, she went, "Why is that?" And so I told her at great length over several cups of tea. And over the next few months, what we did is we honed and refined the sort of vision of what we wanted to be able to do around QA and quality within Deliveroo. And this was in conjunction with the team and stuff like that. And so what you see here is the output of the work that we've been doing and the things we've been thinking about. So thank you very much to my team at Deliveroo and to Sally, who is my manager. Poor lady. So what we did is we took it all the way back to the beginning. And you know, the very fundamental question here is, why do we bother testing software? I mean, our release processes would be a lot faster if we just went, this works, push it live, job done, there we go. This sort of process of testing software takes time and effort, and it often makes people angry as we discover that their work doesn't work properly. Like, why do we test software? And it's so we don't look like idiots. This is really important. Because, you know, what does looking like an idiot mean? Maybe it's something small like at Facebook, we almost pushed the Facebook app live with the inability to log in, which would have been awful and slightly embarrassing, but we could have fixed that with the next thing. But there would have been headlines. Twitter, for example, recently hit the headlines when they accidentally logged everyone's passwords, which was not ideal. Things like that. So the reason why we test software is to try and prevent these problems from trying to not look like idiots. But as we do this, we have a very serious problem. And there are several problems, actually. But the first one that we run into is there's no time for manual testing. Now, I was talking with Michael last night, who hates the phrase manual testing. I'm using it to differentiate from automated checking, which I think is a phrase that lots and lots of people use. But yeah, we have a real problem. There's no time for manual testing. And why is this? Well, let's go back in time. I am an old man with grey in my beard, and I remember the early 2000s. It's actually terrifying. I figured it out. 2018, there are people entering the workforce doing full-time paid employment who never saw the 20th century. It's terrifying. They have no idea what a cassette is. All sorts of fun things. I say things like that in the office, and people sort of go, "The 20th what?" So yeah, so let's say back in the day, in the sort of early 2000s, we used to do infrequent and slow releases. I remember working on a project, and it had a very tight, very aggressive timeline, and that was 6 months. We had 6 months to go from nothing to a released product. And that seemed like a really tight deadline. Like no one could possibly write software this fast. And not only were these releases quite slow, but there was plenty of time for a lengthy QA section at the end of the release process. You sort of wrote your your software, you pushed it to QA, and then they had, a week, a month, 2 months to come back, and then the cycle would go on a bit, and life would be sweet and lovely. And then along came Agile. Now, back in the day, when this was originally like the Agile Manifesto and capital A Agile, and there were a family of these things, it was all quite exciting, but it very quickly collapsed into the sort of sea of mess that we have right now. Like if I was to point at someone who claimed to be doing Agile, is anyone doing Agile? Right. Which process are you following in the many Agile methodologies? Scrum, Kanban, a mix of them, don't really know. Yeah. I mean, there's probably a bit of XP in there as well. Like, the problem is that Agile has become the sort of soup where people just pull the things that they want out of it. But one of the things we did get from Agile is this idea of the sort of bi-weekly, monthly, weekly release. Our release schedules started tightening up. They started coming a lot faster. But, we liked having that nice bit of QA where things were checked and verified and made sure that they worked. How are we going to fit in the whole of the QA cycle with these compressed release cycles? I know what we'll do. Automation. Automation, the tools will save us. Pro tip, the tools will never save us. But the tools will save us. What we'll do more and more automation, and that means that we can do checks to verify that things are working the way they're meant to be working. And then the limited time we have for manual testing, for people to actually do things, aren't going to be spent doing things which are simple, repetitive, error-prone, but they can do the things that human beings are really good at. And that kind of worked, kind of. We started seeing the rise of QA teams, which were actually automation teams. They would spend the entire release cycle carefully crafting, and I take a certain amount of blame for this, Selenium tests to make sure that things were working properly. There was a need for them to become a bit more technical, a bit more programming ability, and there were fierce debates in the community. And then we step forward to 2018, where we are now. Continuous delivery, continuous integration is a watchword, is one of the many, many things that we talk about and that we say is super important. And that means that you get to the stage where you're like Etsy or Deliveroo, where there are many releases, not just per month, but per day. At Deliveroo, we push to production approximately 30 times a day, which means there is absolutely no time to put a human being into that process. I mean, you could put a human being into that process, and all they do is look a bit horrified as they're going, no, I haven't, what, hey? Oh, it started again, has it? There's no time to do manual testing in the traditional sense. And worse, there's less and less time to even run the automated checks that we have. Who here has an end-to-end test suite that takes more than an hour to run? There's a few hands going up around the room. It's not uncommon in the industry to have things that take half an hour, 45 minutes, an hour. Problem is, if you're releasing 30 times a day, well, the maths doesn't work, because there's only 24 hours in the day. I mean, I guess you could make it work by hopping on a plane and sort of following the sun. But it's incredibly tiring, and you don't want to do that. So release schedules have tightened up. We haven't got time to put in a human being to the process in the traditional sense, and we don't have time to do the automated checks that we're used to. So that's a problem. But we have another problem, and that is, particularly the way I've been describing it, and particularly the way it's done traditionally, QA comes far too late in the development process. Normally, the timeline of a story goes, the business analyst does the analysis and everything is lovely, and then the business analyst passes it on to the developer, and the developer, I don't know, bashes the keyboard fruitlessly until something that looks like it might just work finishes. They say it's done, they throw it over to QA, QA go like, what is this? it goes back round, and eventually it gets done by the QA team, so it's then done, and then it gets pushed to production, and it's like done. It's all very musical. But the problem is, there's no way that that QA person should be the first time where someone is sitting there going like, hang on a second, maybe we should make sure this works. Quality is therefore, I like to think of it like steak. If there are any vegetarians or vegans in the room, I apologize. Trigger warning, there's going to be a bit of comment about meat. So steak, I'm a big fan. And you get like really good steak is like, the lean meat in the middle and then big fat rind of fat on the outside, and you try and cook it, and it's impossible to cook that properly, right? You either overcook the lean meat in the middle, or you leave the fat undercooked, or you cook the fat perfectly, and you sort of have this sort of crispy horror of the sort of the lean meat. And that's the traditional QA process, where you have development being the lean meat and QA being the rind of fat. However, the same amount of lean meat and the same amount of fat, where the fat is sort of marbled all the way through the steak, you can cook that and you eat it, and it's delicious if you like steak. You can at least cook it and it'll be lovely. Quality is something that we can't bolt on at the end of the process. It needs to be something that exists all the way through the software development release cycle and through the software release process. We need to be thinking, like, how do we verify that this works from the very beginning? I told you there's another problem. I'm not one to shy away from saying where things are wrong. Occasionally I like to do something helpful, but I begin by telling how everything is terrible and wrong. People they don't respect QA. They might appreciate the things that the QA team does. They might say, thank you very much for finding yet another bug in this piece of software that I thought was flawless. They probably don't say thank you like that. They might go, yeah. And there's another problem with QA. Like, part of it is it's got the name quality in it. And if you give, like, words have power. And if you say to a team, your job is quality, you're telling the other teams that their job is not quality. Like, there's somebody over here who will do this. The developers develop software. They have nothing to do with quality. They have everything to do with bashing on keyboards like half-trained monkeys. People don't respect QA. And you see this all the time. You see it as people saying, testers are a junior role. It's an introductory role to a company. When I was at Google, I used to get people coming through the interview process to be SETs, a software engineer in test. And I would chat with them. I'd go, why? Why do you want to be a software engineer in test? And a surprising number of them were very honest and went, I tried to be a software engineer. I failed that interview. They said I might be good enough to be an SET. And I'd say, oh, that's very nice. I'd do the interview, and then I'd go to the recruiters. I'd go, stop this nonsense. Here's why. Very, very rarely do you come across a company where the QA team outnumbers the development team. There's normally a ratio of 3, 4, 5, 6, 7, 8, 9, 10 developers to one poor person in QA. Does anyone here work in a company where QA outnumbers development? I mean, are you some sort of QA outsourcing company? You're not. I'm very impressed. Slightly horrified, but very impressed. Generally, QAs are outnumbered, and that means that in order to do their job, they need to be influencers. They need to be able to go to the development team and go, by the way, the things you're doing could be improved by doing this. Have you considered doing this? And there's too few of them to force their will upon anyone. They need to be very persuasive. They need to be technically literate. They need to be able to describe things in a way that make the developers go, oh, yes, okay. Those aren't junior qualities. Those are the qualities of a tech lead. Your most senior people are the people who are good enough to be SETs, not the other way round. It ought to be, in that interview, why do you want to be a SWE? Well, I interviewed to be an SET. They told me I wasn't good enough to do that. Maybe I'm all right as a half-trained monkey banging on a keyboard. And testers are also seen as a roadblock. I've heard it so many times. I've finished it, we're just waiting for QA to finish their process. No, I've passed it on to testing, just waiting for them before we can release it. There's that sort of mentality that somehow the test team is preventing us from reaching the sort of golden promised land where everything is wonderful, and these curmudgeonly trolls are sitting there going like, no, you shall not pass. Which is ironic, because that's what their tests are doing, not passing. And this is really sad, right? Like, the reason why they're a roadblock is they're checking the stuff that everyone has done before them, quite often, and they're verifying that work that should have been done far earlier in the release process, far earlier in the development process. They're checking to see whether that has been done properly and safely and in a way that isn't completely insane. And then they go, okay, now that we've verified that the thing boots, for example, we can now poke around and, oh, look, I can't log in. Like, why is it left to them at the end of the process to go back? I mean, we know so much about feedback loops. Like, the sooner you start getting the feedback, the sooner people can figure out whether or not the software is actually working the way it's meant to be doing. And because things are fresh in their mind, the quicker they can fix the bugs. So one of the interesting things is, yeah, words have power. Testing, the way I've been talking about it, isn't necessarily just simple verification. Testing is about quality. It's about not wanting to appear like an idiot in public, so we do these things to try and look professional and like we know what we're doing. None of us really know what we're doing. I certainly don't. But we kind of try and make it look like we do, and testing is about this. Testing is all about quality. And in this particular case, what exactly is quality? Quality is a form of managed risk. Okay? It's not about, it's technical risk that we're taking. You've probably all had conversations like this with project managers. Hey, we want to push. Can we push? Well, there's about 5 bugs that we have outstanding. How serious are they? 3 of them are probably not that serious. 1 of them is just a kerning issue. But 1 of them, we're going to leak people's passwords. And the project manager goes, probably shouldn't do a release there. We know that when we push software into the wild, there are bugs in it. There is no such thing as the flawless piece of software. I reckon there are bugs even in many example Hello World programs, if only because people don't know how to punctuate. But we make a decision, and we do that decision. Like, part of what we do in QA and in testing is provide visibility and information so that people can make an informed decision about whether to release or not based on the technical risk. It's probably going to work. Okay, fine, we'll push it. It's probably not going to work. Okay, well, we're not going to do that. So there is no such team, no such idea, no such concept as quality assurance. It's a thing that we invented for ourselves. It doesn't exist. Like when I was working for a bank, we were writing code and we went, of course banks have bank accounts, right? Like, the very first thing you think about when you think about banks is either robbing them or bank accounts. It turns out banks don't have bank accounts. That is a polite fiction that they tell people. What they have is they have a series of products that they offer you, a savings account, a current account, a foreign exchange account, whatever it is. And you have a product holding, you have an instance of that. At Deliveroo, we talk about orders all the time. I'm pretty sure that an order in the way we talk about it doesn't exist. In the same way, I'm pretty sure that quality assurance doesn't exist. Instead, we have technical risk mitigation. This is the thing we're talking about. We call it TRIM, T-R-I-M, because if you try and pronounce T-R-M, it's like TRIM. It's really hard to say. And this is a team, this is what we do. We take a look at user-focused goals, and we try and reach those goals using developer-focused means. So your developer teams have developer-focused goals, and they do that with developer-focused means. Your design teams probably have user-facing goals, and they're using user-facing technologies to try and do that. We're sort of sitting here in this sort of weird intersection. We need to be able to make changes to software. We know that we should be all the way through the software development lifecycle. We don't want to be the piece of steak with the fat on the outside. We want to be the nice piece of steak. We want to be embedded into the process. And we know that that means that we have to focus not only on the end product, but all the way through. We need to be able to talk to the developers. There was a conference I went to recently. One of the speakers said that quality engineering, QE, is the balance between user advocacy and technical acumen. And some of that rings really true with the work that we do on technical risk mitigation. So I guess now that we've said we're technical risk mitigation, we should probably define what the heck that is. What is technical risk? It's anything that might cause user-visible outages. If it goes wrong, it's a risk. Who are the users? When you think of software products, you're almost always thinking that your users are the person sitting in front of the web browser or in front of the sort of mobile device poking away at it. But within a company, there might be several users. There might be people in sales who are trying to log into your software and do interesting things. There might be people in accounting who are trying to figure out, do we need to pay anyone? Do we need to do that? There may be people in the DevOps community who are sitting there going like, is anything actually working? Things like that. Users aren't just human beings that are using your application as a consumer. It's almost anyone in the company who ingests data from the application you're running. So that sounds like it might be fun, right? We're not just, by the way, relabeling QA as trim. Like, just renaming things doesn't work. The AI community for a long time went AI. They relabeled themselves as machine learning. Doesn't magically move the state of the art forward. Relabeling things isn't what we're doing. We're rethinking things and we're re-implementing it using the modern world that we live in and the technology stacks that we have. Caveat emptor, buyer beware. The focus of this talk is mostly about software where you can iterate quickly, where it's really easy to push, figure out whether something is working, roll it back. If you are working on an insulin pump or a cruise missile or something where it's really important to get it right the first time and you can't ever take it back, maybe hardware, maybe some of these ideas aren't so directly applicable, but the concept and the mindset is. And remember that there are no silver bullets. Like, nothing out there will ever solve all your problems magically and on their own. So I like to break things down into, the joke? There are 10 kind of people in the world. Those who understand binary and those who don't. It's not a very good joke. There's also there's 2 kinds of people in the world. Those who enjoy suspense and... Let that one sink in, sorry. We'll do the technical approaches first. We'll do some of the other non-technical approaches later. So the very first tool in our arsenal, the very first thing we reach for is developer-owned tests. If you have a QA team who own the tests, the very first thing you need to do is start having some tough conversations with the developers. So developers should be writing unit tests. They should be writing integration tests. They should also be writing end-to-end tests. Quite often people go, what I'm going to do, I'm going to arbitrarily draw a line, and after this point, somebody else needs to be responsible for the testing, because there's no way that a developer can possibly be trusted to write an end-to-end test. It's like, you're trusting them to write the actual software. You can probably trust them to write a test. Now, somebody with a testing mindset, someone who can think holistically about the application, the code, the system, can be really useful in helping drive that discussion. So you can sort of walk by and partner with the developers, and you can go, by the way, have you thought about this unhappy path? Have you thought about this particular happy path? Have you thought about, if I have weird letters in my name, like an apostrophe, or, my name is Bobby Drop Tables. And one of the interesting things here is that this means if you write a feature, you own the feature. You own it from the very beginning of the story through to the very end. Your developers don't get to go, I did 15 stories, and you go, how are they running in production? They don't ever get to say, I don't care. They should care. They own this thing from cradle to grave. And I had a conversation somewhere recently, and somebody was saying, oh yeah, my developers move on to new features. They don't bother with tests. They can go faster that way. And I go, do you actually go faster? The tester went like, no. We never actually ship because there are so many problems. They write the feature, they move on to the next thing. Sometimes they don't even bother running the tests that are there. You're going, that isn't a mature, sensible software development. That's a child. Like my 6-year-old boy might do something like that. A grown adult professional software developer should make sure the things they write work. God damn it. We need to look at efficient test runs. We've discussed already, release cycles are getting faster and faster. We've gone from 6 months being aggressive to 2 weeks being the norm to a week, and now we're talking about releasing several times a day. Is there time to run all of the automated checks that we want to? How do we inject human beings into this process? Obviously, we can't run all the automated checks all the time. Fortunately, we are computer scientists. And we can use algorithms and data structures to help us with this. And the most important data structure is the graph, the directed acyclic graph. All of your software has dependencies. Within those dependencies, the software files, the code within them, they have require statements, so they use different bits and pieces. You can draw a line between each piece of source code and the things it depends on. And then when you want to run the tests, you don't need to run everything. That's what we used to do when we were stupid and we weren't thinking. What you need to do is take a look at the graph, reaching from the files that have been changed out to the available test runs, and then you can go, hang on a second, here is a minimal and complete subset of tests that I can run that will verify that this change hasn't broken something using the automated checks. You can do that, it's easy. It's quite hard if you're using something like Maven or Ruby on Rails or something like that. But there are new generation build tools coming out, things like Bazel and Beck. They're inherently based on this graph theory, and they all have mechanisms where you can query the graph and go, what tests do I need to run given that these files have changed? It's a really powerful thing to be able to do. And the other thing as well is you want to try and avoid massively inefficient end-to-end tests. Which leads me to ice creams and pyramids. I mean, you're all here, so you're probably not thinking about Egypt. You're probably thinking about the testing ice cream cone. This is a testing ice cream cone. At the top, you have lots and lots of end-to-end tests. And those are wonderful, and they're probably written by a different team than the ones writing the integration tests in the middle, and a tiny weeny number of unit tests, small tests that are running down at the bottom. This is the ice cream cone. It is terrible. Why is it terrible? End-to-end tests, we know, are the most inherently unstable tests in our entire system. They require everything to be working and working perfectly in order to function. Quite often they end up reaching out to third-party systems that you have no control over, which may or may not be up or may not be functioning the way you expect them to. They may be having downtime of their own. So end-to-end tests are inherently unstable. When they fail, they lack precision. Oh, look, this test failed. Well, what caused it to fail? I don't know. Something in this. You know, have you ever looked at a Java stack trace, which is like several screens long? You're going like, somewhere in here is the failure. I don't know why. And then you go sort of rooting through the code, and then you go, here it is. And then you hook it up to a debugger, and you run the end-to-end test again. And it takes a million years. Like, it's taken me days before to make like a 2-character change because the end-to-end tests have been the only weapon that I have. What we really want is not the ice cream cone, but the pyramid, the test pyramid. I realize this is a gross simplification of automated testing. I realize that. But it is a really powerful conceptual tool. Like, you should have lots and lots of unit tests. Unit tests are great. They're really high precision. They tell you exactly where something has failed because they're testing a single unit of code. And they run incredibly quickly. You can run thousands of these things in milliseconds, maybe a couple of seconds, right? Your integration tests are there going, okay, now that I've made sure the individual units work, if I hook them together, do they function? So you don't need as many integration tests, just by definition, as you do unit tests. And then your end-to-end tests aren't testing unhappy paths. They're not testing that the React developers can correctly propagate a click through down to your component. Trust the React developers. They probably know what they're doing. I'm using them as an example. But you have very few end-to-end tests, and they just verify that the system stands up and functions, and that maybe a couple of key end-to-end happy paths work, so that you can release and people can log in. This is the ideal, the thing we're looking for. And that means that we need to automate at the right level. When a bug report comes in, the developers should never need to write a new end-to-end test. What they should do is run through the scenario and then find the smallest possible test that will work to identify the bug and make sure it never happens again. Quite often, that is a unit test. Very rarely is it an end-to-end test. You can do this. But automating at the right level is super important. Also, think about the value of your tests. If the test is always green, it never fails on the CI runs, and it never fails when a developer is working on the story, is that test adding value? No. But maintaining it is costing time and effort and resources, and running this useless piece of code isn't bringing any value. Don't be afraid to delete things. One of the things that Facebook do is if a test goes flaky or consistently starts failing, they notify the test author. They try and identify who they think is responsible for this test, and they go fix it, and they take it out of the CI builds. If the developer doesn't fix it within 2 weeks, obviously that test doesn't matter. They delete it. It's not providing useful signal. It's just causing cost. We can delete it. And time is limited, so we should definitely avoid Nero testing. What is Nero testing? Fire everything! We should avoid Nero testing as much as humanly and machinally possible. What is Nero testing? Running all the tests on every single possible configuration, just to be sure. Your build pipelines probably go something like build it, unit tests, integration tests, end-to-end tests, fan out like a million different combinations, fan back in again. Do you need to do all that with every single change? I guarantee you the answer is no. You're wasting CPU time, you're wasting cycles, you're wasting your opportunity to move fast and tighten feedback loops. Try and avoid running all those tests. But if there's any doubt, run them. It's better to be safe than sorry. So if you can walk the graph, if you can figure out the minimal subset, do that. If you can't, then I'm afraid you're going to have to carry on being Nero. The other thing is that teams make choices. We all know, that test-driven development ultimately leads you to being able to deliver features more quickly. It slows you down to start with. It takes a while to write those tests, and modifying those tests can be painful. But because you're not going back all the time fixing bugs and trying to correct things and trying to understand like why, playing whack-a-mole where you fix something and another bug comes up, so you fix that and another one comes up. TDD allows us to move more quickly. And you should have that conversation with your teams, but you can't force them to do it. There's an expression in the English language. You can lead a horse to water, but you can't make it drink. You can show the developers, hey, look, this will enable you to go faster. If they don't want to do that, it's fine. Can't force them. They don't want to do it. If they do it, they'll do it in a bad way because they're not really committed to it. But one of the key things is that you should also make it clear, and you should get management buy-in, that developers are responsible for the code that they write. And that means the developers are on call. They hate this. Well, they hate it if they're in an organization where they've never had to care about quality before. Suddenly being made responsible for holding the pager and waking up at 3 o'clock in the morning when the site is down makes them grumpy. Ideally, that should also make them go, how could I avoid being woken up at 3 o'clock in the morning? The problem is, most of the code is so awful that most people in that point are sleep deprived and they're not thinking clearly. You, as a member of the trim team, are well rested because you haven't been writing the production code, so you can avoid being on call most of the time. The developer who wrote the feature is on call. Now, the nice thing with this is that means, does anyone have SREs, site reliability engineers, or a DevOps team? DevOps team makes me so angry. It started off as a mindset, like, oh, what we're going to do is we're going to have developers and the operations folk talk to each other, conversations. It's a radical idea. And we're going to be nice, and we're going to figure out how to work effectively together as a team where, you have this mix. And what it basically has boiled down to is your sysadmins now get called DevOps. It's just a title change. It's just so frustrating because it's meant to be a mindset change. But your SRE team, your DevOps, in the model where developers are on call, become third-line support. They're the ones who can diagnose the system, who understand where everything is working, where everything is not working, and can go in and fix things. It's super powerful. At Google, the SREs are a sort of treasured resource. When an SRE arrives on your team, it means they think your software is stable, and it means that they think they can have a good night's sleep while your software is running. And that is high praise indeed. Another thing that we've observed, staging doesn't help. Your UAT environments aren't helpful. They're a bit of a dumpster fire. They don't reflect reality. That's the problem. They're, even if they have the same back-end services, which they may not, because some of those cost money, you're running on the same database. It's probably not the same size. It probably hasn't got the same amount of data in. The caches are warmed differently because the traffic patterns are different. If you have a shared staging environment, it looks nothing like production because you've got 15 changes in flight. If something doesn't work, which one of those 15 things is it that's caused the problem? Staging environments are a useful idea where you sit there and you go like, I think I just need to spin this up, but we put a lot of effort. Like I've seen teams focus all of their testing efforts on staging. None of your customers use staging. Why are you? So what you really want to do is you want to test in production. That's where your users are. That's where it all gets very exciting. And we live in a brave new world. We have all these options available to us. These are the two key building blocks, staged rollouts and feature flags. A staged rollout, you should be able to push a new version of your software into production and slowly start trickling traffic into it to address whether or not you think it's working. And you might start with just members of your company. And then you might go, okay, members of the company and trusted testers. Okay, now I'm going to put 10% of traffic on. Now I'm going to put 50% of traffic. Okay, now I'm putting it live and rolling it out everywhere. In a world where there are microservices, you actually can't do atomic rollouts anymore anyway. You have an uncontrolled staged rollout, so you might as well embrace it. And feature flags are wonderful, because what it means is you can push a new thing into production, and then you can do some testing based on who the user is. You can make an assertion based on who the user is, and then figure out whether they should go through the new code path or the old code path. And it means that if you discover a terrible, terrible bug, it's that fast to switch it off. You just go, hang on a second, disable the feature flag. We'll just make everyone go through the old code path. And you can do this when you're releasing really frequently. Interesting thing about feature flags, Facebook use them extensively. And they have a system called Gatekeeper, which basically checks to see whether or not you have access to a feature. One day, somebody pushed an update to Gatekeeper, and it failed to open. So it said yes to everything. It's a very positive experience, embracing life. Yes, I'll do everything. They called it Release Everything Day, because all the things that they were working on suddenly became available to the public. So you've released into production, you're doing these staged rollouts. How do you know whether or not the software is working? Well, we're going to move towards observability. This was a phrase that was coined by Twitter, I believe, in one of their blog posts. And there are lots of people talking about it, but Charity Majors and her company Honeycomb talk a lot about it very articulately, and they have products based around it. What is observability? It's based on 4 key pillars. Monitoring. Hey, look, what's going on? Alerting. Oh, crap, it's all gone on fire. Distributed tracing. So something's gone wrong. Can I follow the request through all the systems it touches? And in a microservice architecture, this is really important because you're probably flowing through more than one system at a time. And finally, log analytics. So when something does go wrong, you want to be able to go back in time, take a look at the things that have happened in the logs, and figure it all out. Observability is key. If you're testing in prod, you're doing stage rollouts and feature flags, you want to be able to verify that these things work. So observability is a sort of fundamental part of what we do. Technical approaches, they're fine, but we also want non-technical approaches. What is it that makes your QA team stand out and be different from just the normal developers? Like, we all code now. We all ought to code now. My son, who's 6, he gets taught how to code at school. The argument that testers shouldn't code is bogus. Everyone should code. They don't need to be great at it, but they should know it. The thing that makes testers really unique, and your QA team just a wonderful asset for your company, is they have a holistic view of the system. They understand how the system is meant to work end to end, and they understand its success modes, and they understand its failure modes. Almost no other person in the company understands the system as well as your testers and QA people do. When I arrived at Deliveroo, one of the questions I asked was like, how, it's a system where people can sort of fire up the app, they order some food, something happens, food arrives at their door. It's like, how does that process work? And I got pointed towards one of the QA people, Charlene, who went, okay, here's how it works. She walked me through the entire system, all the interlocking applications that people use, the things that the riders use, the restaurants use, that the customer uses, that the customer service people use when there's a problem, showed me how everything worked. No one else in the company had that same view, to that same level of detail. They couldn't walk me through a worked example of it. That holistic view is super important and must never, ever be lost. So how do we apply that sort of holistic view toward what we want to do as a trim team? Well, the first thing that we need to do is identify user-facing metrics. And this is a conversation with the business. This isn't a technical conversation. This is a conversation with the people who are actually consuming this data, the thing that we care about, the users. They're not consuming users, that would be terrible and cannibalistic, but they are the users of the data. Does that make more sense? Yes, okay, good. I mean, eating users would be terrible. Solve a few problems, though. So they identify user-facing metrics. These are the things that we actually care about. These are the things that we want to page on. Don't really care whether the read time from Redis has gone up or down. We don't really care about the load on the database. We don't care about all manner of things. What we care about is, can people receive their food? Or if you're a bank, like, are the transactions looking appropriate? At Facebook, they used one metric to determine the health of the system, and that was data ingress and egress. So you could see whether something was wrong by taking a look at the average amount of data going in and out of the system. And if that number dropped precipitously, you knew something had broken. And if it climbed precipitously, you knew something had broken. And I found this out when being introduced to how Facebook check all their data. Chap was going, oh yeah, we have this line here, and he turned around and it was fine. And if anything were to happen to that line, we'd be notified, and we'd have a bit of an emergency on our hands. And then somebody sort of raises their hand and goes, excuse me. The person running the class goes, what is it? And the person goes, like that. And the line had dropped down to 0, and somebody had broken the like button across the world, and the person running the class ran out. So identify user-facing metrics and use those. Beta programs are a really powerful tool as well. So manual testing, prodding the application, using it in new and unusual ways. Your users use your app in ways you will never imagine. I know this because of the bug reports I get on the Selenium project. There's madness out there, and the things they do is crazy. People who enroll in beta programs are super enthusiastic about what it is that you're doing, or they're being paid to care, which is almost the same thing. Beta programs are great. They're a force multiplier. It can take one person on the trim team to run a good beta program, and that could have 1,000 people in it. But it means that you need to have mechanisms in place for collating data that comes in. Like if you have 1,000 people constantly providing feedback, you need efficient mechanisms in place for figuring out how to filter that, arrange it, group it, identify patterns and trends and things like that. This is where the trim team come in handy. They're sitting there, one of them is running that program, collecting that data, and they know and can communicate what that is. I always think of it like, why have one manual tester when you can have thousands? And the nice thing is they are going to use your application in weird and wonderful ways, but they're going to use the application in the weird and wonderful ways that your users are going to use it, which is wonderful. So at every point in the software development lifecycle, the SDLC, risk is added. Testers can help add value at every single stage. At the beginning of the point, when the BAs are sitting there, they can sit there going like, have you thought about happy paths, sad paths, what about this, what about this, what about this? And that can feature into the story development even before coding has begun. When the developers are working on a unit test, just having a conversation with them going, have you thought about these considerations? Here's how people are going to use it. Oh, by the way, we've seen this happen quite a lot. Just make sure that's okay. Those conversations add value. And then when we push to production, being able to figure out what the user-facing metrics are is super important. It allows us to go, yes, this is working, or no, it is not. And it allows us to address that. Weirdly, faster releases reduce risk. How does that work? If you have the mechanisms in place to determine whether or not the software is functioning the way you want it to, then if you release 20, 30 times a day, the number of changes going in is 2, 3, 4 changes maybe. You know, very few of us are at companies with 6,000 developers. Like Deliveroo has something like 150. So pushing 30 times a day means that 30 of them are actually committing something to master. At least 30 of them are committing something to master that we think is worth pushing. Which means that those changes that happen in production, when something goes wrong, there's a smaller subset of data to read through to try and figure out what caused this problem. If you release once every 6 months, you probably have batched thousands of changes. And identifying what caused a problem when there are thousands of changes, thousands of variables, is terrible. We all know as testers, as people responsible for quality, that the best thing to do is to change one variable at a time when you're trying to diagnose a problem, because then that allows you to hone in on what the problem is. Faster releases reduce risk. which seems counterintuitive. So we're kind of mentioning lifecycle and things like that. There's a model I like to use to think about technical risk when viewing a product lifecycle. And that's Beck's 3X model. Has anyone heard of this? Beck is the father of extreme programming. He's one of the original signers of the Agile Manifesto. He's a lovely chap. And in Britain, when we're teaching children in the early years, we teach them the 3 R's, reading, writing, arithmetic, which everyone knows don't begin with R. In the same way, 3X, none of the words begin with X. It's not xylophone, zephyr, and Xavier. Explore, expand, extract. Let me tell you a little bit about these. Explore. This is the phase in the software lifecycle where you don't really know what it is you're doing. You've got an entire problem space, and you're just hunting for a solution. You're trying to do something interesting. So maybe if you're a company working on a product, you're going, we could try this, we could try this, we could try this, we could try this. Those experiments are cheap, they're fast, the iteration is quick. If that's the case, then technical risk is low. What you're doing is you're probing the space to find out the direction you should go in. So you probably don't need an awful lot of testing. You can apply your testing efforts to where it's needed. And where it's needed is in the second phase, where you're expanding. So what happens is you finally find something that looks like it kind of works. And so what you're going to do now is you're going to start putting business risk on top of it, technical risk on top of it. So it might be where a product finally gets some traction in the market, people like it, and you think, hang on a second, we should probably develop it from the minimal viable thing we have to something a bit richer. And this is the expand stage. At this point, you're adding features. As features are added, they have a big incremental improvement. So there's a sort of steep increase in capability. So there's medium technical risk, but the reward for making changes to the company, the value it adds, is also increasing. It's less than it was before. Like you haven't discovered a new iPad, you're refining the iPad. You're doing something clever. This is a really good time to get the trim team involved and have a discussion about, hey, look, how do we look after this thing going forward? What do we do? And then finally, we reach the final stage. This is where the product is mature, it's stable, any changes you make are incremental, they're minor improvements. It's a bit like the gap between the iPhone 7S and the iPhone 8, where it's a sort of small improvement of the technology. And at this point, changes are very risky. You don't want to, this is probably now on the money stream of the company, or it's important in some very, very technical way. So any change is high risk, and there is comparatively low reward for making this. So your testing procedures had better be, weirdly, very good, because this is a point where if something goes wrong, it actually starts costing money and has a deleterious effect on your company. So the 3X model is a really useful one that I have in my mind when I'm trying to figure out, like, is it worth talking to this team? Is it worth trying to address this problem? How do I do this? If I look at like a company and I come across it, there are going to be different parts of the product, different parts of the company in different phases of this 3X model. Like maybe the underlying infrastructure is old and established. That's in the extract phase. But maybe somebody is starting a new project to see whether AWS Lambda is an appropriate way forward. Well, that's in the explore stage. So one company isn't always at a homogeneous place. It can have different things within it. And even within a single product, you might have different things at different phases in the life cycle. So take Facebook, for example. Old established product, you'd imagine everything would be in the extract phase. But then they try out things like stories. Does it work? Does it not? I don't know. That's actually right at the beginning in the explore phase. So they're addressing these things. So in summary, QA as we know it is gone. Death to QA. The king is dead, long live the king. Long live trim. Technical risk mitigation is the way that we should be thinking about and communicating technical risk and what it is that we are trying to do. Risk management is a conversation. You never ever get to impose things on people. Risk management is always about persuading people that this is something they want to do. And you can show them the pros, you know the costs, you can explain these things, you can be articulate. But it's all around communication. Risk changes in every part of the software development lifecycle. It actually increases in every phase. When you have no code, there is no risk. The closer you get to production, the more the technical risk increases until you are finally in production. And then the technical risk continues to increase while you're in production. There was a recent security flaw where somebody hadn't upgraded their version of struts in a long time, and that was a real problem. If they were constantly addressing technical risk, being able to do fast rollouts, they should have been on top of that. But technical risk doesn't end once you reach production, it continues going forward. And technical risk changes in each stage of a project's lifecycle. So the further through the product's lifecycle it is, the more risky changes become. And so we should have processes and ideas and approaches for dealing with that that are appropriate. Now, I said that to the organizers, that I was going to try and leave some time for questions. We have 5 minutes left. Thank you all very much for listening. I really appreciate it. I hope it's given you some food for thought, and I hope you have a great conference.
У нас есть некоторое время на парочку вопросов. Вопросы нужно задавать на английском языке, наверное. Поднимайте руку, к вам подходит специальный человек с микрофоном. Например, я или Ксения. We have a couple of questions.
Yes, I'd love a couple of questions. I mean, I can make some up if that would help.
Yeah. Hello, thank you for this great presentation.
Thank you.
When you say death to QA and when you say it's going to be like replaced with stream, what do you mean by technical risk? I'll expand a bit. By technical risk, I would understand the risk about coding, the risk about infrastructure, the risk about integrations with other systems, so like really technical stuff. What about the risk on UX stage, on business analysis stage, on defining and eliciting requirements? I mean, high quality to me is not only about working by requirements, it's about satisfying the need.
Yeah.
My definition is quality is an ability to satisfy users' needs in time, today, tomorrow, in a year, in two. It's not only technical to me, and there is a lot of room for conventional QA to me.
Okay, so boiling that down, what is technical risk and why should we focus on it? There are parts of the company that are already set aside for dealing with other kinds of risk. So there are financial risk, for example. You probably have an accounting team or a legal team who are looking at that. Legal risk is another thing. We at Deliveroo have people focused entirely on security. So we don't worry about the risk about penetration testing or security risks in that particular sense. Product owners are responsible for the risk of, is this the appropriate product to be building? So if you just call yourself a risk team, the coverage of what you're trying to do is super broad, and it's so broad, you either become the entire company or you struggle and you drown under that weight. So when we talk about technical risk, there was a slide earlier on in the deck. Technical risk is risk of something that is user-facing going wrong. And that user doesn't necessarily need to be an end user. It could be someone who is just consuming the data that you are generating. So maybe your DevOps team are users of the logging that you're generating, for example. Maybe the accountants team is needing to be made aware of the fact that there could be a problem. Like, have you suddenly seen a spike in fraudulent transactions occurring? Like, what does that tell you? So, yes, I'm not saying that QA is worthless. What I'm saying is the way that we have traditionally structured our quality assurance teams isn't appropriate for the modern era, and we need to rethink about how we embed ourselves into everything. And so that's sort of what we do with the trim team. I'm happy to talk about it later, but I think we are basically out of time. Thank you, ladies and gentlemen. I appreciate it.